Scientists built the most powerful telescope in human history. They pointed it at the early universe, and what they found broke their own models. Galaxies that shouldn't exist, atmospheres on distant worlds, ancient light from a time when the universe was barely a baby. The James Webb Space Telescope has been in operation for just a few years, and it has already forced astronomers to rewrite what they thought they knew. This is what it found, and why it matters more than most people realize. Here's the thing about Webb that most people miss. It isn't just an upgrade on Hubble. It sees the universe in an entirely different way. Hubble worked mostly in visible light, what your eyes can see. Webb works in infrared, heat signatures, longer wavelengths, light that has been stretched across billions of years of cosmic expansion. That means Webb can see things Hubble physically could not. Older things, fainter things, things hiding behind clouds of dust that blocked visible light entirely. Webb doesn't just see farther. It sees deeper into time. I've been following the Webb mission closely since before it launched, tracking the science, breaking down the discoveries, and translating what astrophysicists are actually saying into something a human being can understand. And I want to tell you, some of what Webb has found is genuinely unsettling in the best possible way. It's the kind of science that makes you feel the ground shift a little under your feet. Here's the plan for today. We'll start with Webb's very first deep field image and what it revealed. Then we'll get into the galaxies that broke the standard model. After that, we'll talk about what Webb found in the atmospheres of distant planets. Then we'll cover a discovery that hints at something nobody expected in the early universe. And finally, the one finding that has cosmologists losing sleep right now. Let's go. In July 2022, NASA released Webb's first deep field image. It was the deepest infrared image of the universe ever taken. In it, captured in just over 12 hours of observation, you can see thousands of galaxies. Some of them are gravitationally lensed, their light bent and stretched into arcs by the mass of galaxy clusters in the foreground. That lensing effect acts like a natural magnifying glass, letting Webb see even farther behind the clusters. One of the galaxies captured in that image existed when the universe was less than 1 billion years old. Its light has been traveling toward us for over 13 billion years. We are looking at something that ancient, with a clarity that has never been possible before. And this was just the first image, just the beginning of what the telescope could do. But then things got complicated. Very quickly, Webb started finding galaxies that were not supposed to be there. According to the standard model of cosmology, the framework astronomers have used for decades, the early universe should have been mostly smooth. Structure takes time to build. Gravity pulls matter together slowly. Large, mature galaxies with organized shapes and billions of stars should not exist in the first few 100 million years after the Big Bang. There simply hasn't been enough time for them to form. Webb found them. Anyway, astronomers looking through early Webb data discovered what they nicknamed the cosmic elephants, massive, well-formed galaxies sitting at redshifts that place them in the universe's first 500 million years. These galaxies are large, they are structured, they have stars, lots of them. One study identified 6 candidate galaxies so massive that, if confirmed, they would contain more stellar mass than our models say should be possible at that age. One of the lead researchers described it as finding an adult in a room full of toddlers. This isn't a small discrepancy. These galaxies being where they are, as big as they are, challenges the timeline of how structure forms in the universe. Scientists are still working through the implications. Some say the models need adjusting. Others say there may be new physics at play, processes in the early universe that accelerated star formation in ways we don't yet understand. Either way, Webb found something that genuinely doesn't fit, and that is exciting. Now let's shift to something closer to home. Relatively speaking, one of Webb's primary mission goals was to study exoplanet atmospheres, the thin shells of gas surrounding planets orbiting other stars. And here, Webb delivered something extraordinary. In 2022, Webb analyzed the atmosphere of WSP-39b, a hot gas giant orbiting a star about 700 light-years away. And for the first time in history, astronomers detected carbon dioxide in the atmosphere of a planet outside our solar system. Not inferred, not estimated, directly detected with a clear chemical signature in Webb's data. This was a landmark moment. Carbon dioxide is a molecule we associate with planetary atmospheres, and on Earth, with life. Detecting it elsewhere is a critical step toward eventually identifying biosignatures, signs of biological processes, on distant worlds. But Webb didn't stop there. It also found sulfur dioxide in WSP-39b's atmosphere, a molecule that, intriguingly, appears to be produced there by photochemical reactions driven by starlight. The planet's chemistry is being actively shaped by its star in real time. Webb watched it happening, and WSP-39b is just a test case. Webb is now turning its instruments smaller, rocky planets, including those in the TRAPPIST-1 system, a collection of Earth-sized worlds orbiting a nearby red dwarf. Some of these planets sit in the habitable zone. Webb is currently probing whether any of them have atmospheres at all. The results so far are mixed and still coming in. But the fact that we can even ask this question and get real data is a revolution. Now, here's where it gets truly strange. Webb has been detecting light from some of the earliest galaxies ever observed, objects from the universe's first few 100 million years. And inside some of that ancient light, astronomers found something that raised immediate questions. Signs that some of these early galaxies may have hosted supermassive black holes. Already, in the infant universe, black holes are supposed to grow over time. They consume matter, they merge, they build up mass across billions of years. Finding what appear to be very massive black holes this early in cosmic history, before the universe had time to build them by conventional means, is deeply puzzling. It suggests either that black holes can grow much faster than current models allow, or that some black holes formed through different mechanisms entirely in the universe's earliest moments. Mechanisms we haven't fully mapped out yet. It is a thread that, when pulled, could unravel and remake large parts of our understanding of how the universe evolved. And now, the discovery that has cosmologists most unsettled right now: the Hubble tension. This is not new. It has been brewing for years, but Webb has made it worse. Here's the issue. There are two main ways to measure how fast the universe is expanding, called the Hubble constant. One method looks at the early universe, the cosmic microwave background, the afterglow of the Big Bang. The other method looks at nearby galaxies and standard candles called Cepheid variables and type Ia supernovae. Both are rigorous, both are well tested, and they give different answers. Not slightly different, meaningfully, stubbornly different, in a way that can't be explained by measurement error alone. One of Webb's tasks was to check the nearby measurements with greater precision to see if Hubble's observations of Cepheid variables contained errors that explained the discrepancy. Webb looked. The measurements held up. The tension didn't go away. If anything, Webb confirmed it more firmly. The two values of the expansion rate of the universe genuinely disagree. And that disagreement might mean there is something missing from our model of the universe. A new form of energy, a new type of particle, or a process in the early universe that we haven't discovered yet. Scientists call it a crisis in cosmology, That is not an exaggeration. So let's land this plane. Webb's first deep field image gave us the clearest view of the ancient universe ever captured. It then found massive, mature galaxies in the early universe that shouldn't exist by our current models. It detected carbon dioxide and sulfur dioxide in the atmosphere of an exoplanet, a first in history, and is now probing rocky worlds for signs of atmosphere and possibly life. It found hints of supermassive black holes forming impossibly early, and it deepened the Hubble tension, the growing crack in our standard model of cosmology that suggests something fundamental is still missing from our picture of the universe. Webb has been operational for just a fraction of its planned lifespan. It has fuel for over 20 years of observation. We are at the very beginning of what this telescope will show us. Now, I want to hear from you. Which of these discoveries hit you hardest? The galaxies that broke the model? The planet with a detectable atmosphere? Or the Hubble tension that has cosmologists genuinely worried? Tell me in the comments. I read all of them, and I genuinely want to know where your mind went. Stay curious. The universe is rewriting itself in real time, and Webb is watching.